We're going to try an example from Chapter 3, Section 3.12, and that section is entitled Conformational Analysis of Di-Substituted Cyclohexanes. Of course, cyclo means ring, hex means 6, so it's a 6-carbon ring. Di-substituted means there are 2 groups. So in this case, we're going to do an example where we draw both chair conformations of trans 1-ethyl 2-methyl cyclohexane. The 2 groups that are substituted instead of hydrogens are an ethyl and a methyl. Trans means that these 2 groups are not close to each other, but across from each other. So one way to show that is to draw a 6-membered ring. Here I'm not doing the chair quite yet. It's important to start with your flat hexagon first. And if we number a couple of carbons, it doesn't matter where you start. I'm going to choose this carbon to be number 1 and this carbon to be number 2. If they're going to be trans, 1 should be up and 1 should be down. So let's say we make the 2-carbon group 1, 2 up, so that's an ethyl, and our 1-carbon group down, so that would be a 2-carbon group up, a 1-carbon group down. Those are trans from each other. Another way to show this, instead of it showing it vertically up and down, if we redraw our 6-membered ring, is we could say, instead of up, you can draw it as a wedge, and here I've drawn an ethyl here, and instead of vertically down, you can draw a dashed line, and here I've shown my methyl there, again on carbons 1 and 2 of the ring. So if we're going to do this with a chair, you start off making a chair any way that you would like. 2 offset parallel lines. The foot of the chair comes down, the head of the chair comes up, and if we kind of look at our number 1 and 2 carbons, again, it doesn't really matter where you start. Let's say that's carbon number 1, and this is carbon number 2 of the ring. So now we're going to show our ethyl and our methyl. At the foot of the chair, the axial position is always going straight down. Then the axial positions alternate up, down, so if number 1 is down, number 2 should be up. The equatorial positions would be going out away from the ring. As long as they're not up, down, vertical, you're okay. So on carbon number 1, it's clear that the axial position is pointing down, and then that makes the equatorial position must be pointing up. So if I put my 2-carbon ethyl group at the higher up equatorial position, then on carbon number 2, it's clear axial is up, so equatorial must be down. And if I want my methyl to be down, the wedge or vertical down, I could put CH3 here. Now, for those 2 axial positions, here and here, if I leave them that way, it implies that there's a carbon at the end of that skeletal structure. So that would not be okay. They're really just hydrogens here and here, so I could draw those on. Similarly, if I wanted to draw them on my previous structures, like here, I could have drawn a hydrogen and a hydrogen. So carbon number 1 has a hydrogen down, ethyl up, hydrogen down, ethyl up. Carbon number 2 has a methyl down, hydrogen up, methyl down, hydrogen up, something like that. That's one of the chair positions. If we were to do a ring flip, a ring flip is where you rotate the head of the chair down and the foot of the chair up, all of these axial and equatorial positions are going to reverse. So again, I'm going to draw my two offset parallel lines. Now on the left, instead of going down, on the left, it's going to go up, and on the right, my chair is going to go down. So if we were to number these carbons, carbon number 1 used to be down on the left. Carbon number 1 is now up on the left. Carbon 2 over here. Carbon 2 over here. And the head of the chair always has the axial position pointing up, and they alternate, so carbon 2 must be pointing down. Equatorial should just be pointing away from the ring somewhere. And on carbon 1, the ethyl used to be equatorial, so now it should be axial. And the methyl used to be equatorial, so now that methyl should be axial. So basically they've reversed. So it used to be equatorial, equatorial. Now it is axial, axial. Your axial and equatorial groups, of course, reverse when you do a ring flip. So finally, another thing that is often asked about these kinds of chairs is which one is more stable. You might remember that larger groups are better at equatorial positions because they're sticking out away from the ring. So in terms of which one is more stable, here the ethyl and the methyl are both equatorial. That's a little more stable. So that gives me our answer.